Okay, I hope it looks right. Just try it out. How? Oh, okay, it's moving. All right, the pressures of the last one, just right before lunch. So hope you will enjoy what I'm going to present, and you can relax. So hello everyone, I'm Tracy from Taiwan, and I'm working in an architecture school in Taiwan as an assistant professor. And so just started my work there, and as I mentioned, I used to work as a green building consultant, working with leads and all this kind of certificate. And what really annoying is the process of turning a BIM model into an energy model. So this got me started with this review works. Hopefully you also find something you didn't know and something you can work on. Right, so as I mentioned, in the past, as a building consultants, we work with simulation tool, and you need to import the drawing, input a lot of information. And after the BIM era, people's feeling like, oh, this is cool that we can extract a lot of information, but in practice, it's not working well. Yeah. So, and why is that? It's because even though BIM as a rich model provide a lot of information, geometric information, semantic information, but during the data, the format transformation, and the process just result in a lot of information loss. And the energy application need more than that. It needs information and knowledge of the HVAC system, and it needs the knowledge of user, their occupant behavior, and in an AI era, and also needs machine readable data, etc. Yeah, so in recent years, ontology is not the new things, but knowledge graph, and also because and I think all this semantic approach grow viral, gain a lot of attention. And so the beauty of them, the beauty of ontology and knowledge graphs lies in it can foster data automation, increase interoperability, and in the for digital twins, and it's important for later on simulation and all this AI model application. So that's what I did. I used Scopus, and I used the keywords. I used BIM, I used ontology and energy and knowledge graph at the same time, and I got 31 paper. And so when I look into them, I look into the lifecycle phase, and I also discovered that this paper not only just limit to the building scale, and a couple of them now they start also working at the urban scale, district scale. Yeah, and so this is just a trend of how this paper got published. And in the beginning, there's a more exploratory study, and recently AI and knowledge graph really become popular. And then that is the different phase and spatial skill. So in the beginning, of course, there's a lot on the building and operation. Half of the paper focusing on using ontology for the building energy operation case. But design is also important in the building process for sustainable building. So, and in the early phase and also in lately is also still an important focus. Right, so these are the some key cluster for the design phase and for the building and for the urban level. So for building, of course, a lot of discussion is on whether we can match the requirement for all this energy simulation, and also how can we automate the process, turn from the BIM model to a BIM model. But when we talk about semantic BIM, a lot of people think it's only about the attributes, the semantic information, but it's more than that. The latest paper also saying that through another knowledge graph, you can also review the geometric relationship between the important components in the BIM model. For example, the zoning, whether the zoning class again one another. So you can also help with reviewing the geometric information. Right, and if we're at the district level, it's for the planning phase, and it's about linking the IFC and CTGML, etc. And for the operational phase, of course, a lot is about how can we utilize ontology and do a better building energy management. And then the carbon also coming to the picture. And of course, a lot of linking different type of data, the ILC data. And turning the BIM model into the BIM model is also important in this phase, is to feedback, getting the actual operational data and to feed it back to the BIM model and do a better simulation and better operation. And of course, AI again, and this is related to the graph machine learning. And then for the district level, in other words, urban building information modeling. Now we're looking at a lot of district scales because smart grid discussion. So people also start using knowledge graph to simulate a district level of multiple building energy performance. Right, the last I have a label as whole life cycle, because 3 paper lately also claim that we should do this feedback after how can the ontology or the knowledge graph develop from the beginning, the design phase, and all the way to the operational phase. How can we have the persistence, knowledge structure, etc. And also some interesting projects, I think very similar to the first presenter. How can a city or the country start working on their digital building log? And so all this data can be knowledge base for a lot of application in the future, right? All right, this is what people need to know when you do a lot of literature. So where are the gaps? So what else can we do? Well, a lot of things it's imaginable, understandable. Like across the life phase, is still quite fragmented. And regarding to the scale, from the building to the district scale, it's definitely a new research field. And even though we regarded ontology and knowledge graph as a good approach for interoperability, I think the first presenter also addressed the size of the ontology is also the problem. So if we have a better communication or translation in advance, and that will also help the process. And another key words that people have been talking about is neural symbolic AI. So this is integration of how the symbolic AI and the more traditional machine learning neural AI can join together, work together. And the last but not the least is always about whether we can trust the ontology you create, or the ontology that machine robot create. So human in the loop, it's definitely still a big research topic that we should work on. Right, and this is more like a conclude slide I made. It's so through this 4 layer, we can understand how we can create a ontology-based or knowledge-based framework or architecture, and what are the key elements we should have. And at the moment, the blue line is very understandable, but the key question is how can we provide the orange slide, the feedback loop. Yes, how can we feedback all those gain and what we learn from the operation and back to the ontology we create in the first place, etc. Right? I don't know whether it's less than 10 minutes,
Yeah,
but
it's perfectly 10 minutes.
oh, wait, but I have a mission. I come with a group of people, so the leading professor would like just to say hi. Welcome you all to Taiwan. One day we're coming from all this different university here, and there's a coming interesting conference, not held by uni, but one of the participants uni. So it's about equity, social sustainability in the sense, but also for the engineering field. Thank you for your attention.